Right. So, in this lesson, we're going to learn two different ways that we can solve a quadratic equation. This objective here actually in the end will include many more things than just not many more, but more than just what we're doing today. But the two things today that we're going to do is solving an equation by factoring. That's why we learned to factor, and solving an equation by graphing, which, to tell you the truth, kind of requires that you have a calculator in hand. And because you don't have a calculator to take home with you, I can't really give you homework related to that one thing. But we'll still go over, the principle of it is important to understanding the next thing we do, why the quadratic formula gives us the kind of results that it does. Okay, let's see. So again, making the distinction here between what is an expression and what is an equation. Right? We learned in the last lessons how to factor a quadratic expression. Right? In this lesson, we want to learn how we can solve a quadratic equation, because that's what you do with equations. You solve them. Right? Now, up till now, with the kinds of functions that we knew, which are really only, the kind of equations that you can always get all the variables on one side and the answer will be on the other, we can't do that now because the variable is in two different terms. One is squared, one is not, which means they're not like terms. You can't put them together into one term so that the variable can be isolated. So our strategy for solving equations right now won't work. Not on all quadratics. It will work on some, but not all. Right, so these are not like terms. They can't be combined, so you can't isolate the x into one term. So we need to come up with different strategies for quadratic equations like that. Okay, good. Okay, now we are going to factor our quadratic expression like we learned in the last couple of classes because of this property, which is called a zero product property. Right? A product means multiply two things. When you multiply two factors and you get a zero as a result, the only way that can happen is that one of those two things that you started with must have been zero. Right? You can't take two non-zero numbers, multiply them together, and get a zero. It just doesn't work. Right? That's a property of zero is, right, if A times B is zero, then either the A is the zero or the B is the zero. I mean, that is a really powerful property that we use to solve lots of algebra equations. And that's why we learn to take an expression, which is not in a factored form, and put it into a factored form, because we'll be able to solve that way. Our new pre-calculus book changed the name of it. They call it the zero factor property, but it means the same thing. I've never heard it called that. I don't even remember hearing it being called zero product property, but it's more like a property of zero. Do you have questions, Sam? Okay. Good. Okay. You ready? Anybody else? Do you need? Okay. So here's how we do it, right? These are the steps. First of all, you got to be starting out with a quadratic in standard form equals 0, right? We don't have any parentheses or anything else going on. It's just the squared term, the x term, the constant term equals 0. If it's not in that form, you got to put it into that form before you start. And that's true for other methods of solving quadratic equations. You usually always start out with 0 on one side, everything else on the other. Now, all the problems I'm going to show you here, or have you do, come from our homeworks in the last couple days, right? I've just taken the factoring problem in some way and set it equal to 0 and said, okay, now let's solve it like we were solving an equation, right? We already learned the fact, this was our very first homework problem, number 11 on page 221, right? And it was a simple quadratic because this is a 1. And we said, what two numbers, the product is 2, and the sum is 3. And we said 2 and 1. So we converted from standard form to factored form. Okay. Now, in this form, this is like the zero product property on the last slide. We're multiplying two things together, right, and getting a product of 0. That tells us that either the x plus 2 equals 0 or the x plus 1 equals 0. One or the other has got to be 0 because that's the way you get a 0 through multiplication. So you can set, right, let me change my color. Just set each factor equal to 0, right? Set x plus 2 equals 0 and set x plus 1 equals 0. And those are equations you can isolate the x. So you do. Right? In this case, subtract 2. In this case, subtract 1. Okay, so notice another thing that's a little different than what we've done. Maybe if you remembered absolute values, when we solved absolute value equations, how many answers did we get? 2. And here, when you solve a quadratic, you get 2 answers. You always get 2 answers. Right. So we're going to do a few of these, but for the most part, we're just going to be taking the different kinds of factoring we did and turning them into equations and solving. So it ends up being an exercise in factoring and then taking it one more step to solve the equation. Okay, so again, solve by factoring. What do I have to do to this one before I can start the factoring process? It's got to be standard form equals 0. There's no 0, so how am I going to make it 0 on one side? How about subtract 75, right? If I subtract 75 from this side, and I subtract 75 from this side, now I've got x squared plus 10x minus 75 equals 0. Right? Do you remember that homework problem? What were the factors of negative 75 that added up to 10? If you go back 2 homeworks ago, you've got it. What are the 2 numbers? Number 75 could be 1 times 75. Could it be 2 times something? Is 75 divisible by 2? No. How about 3? 3 times 25. How about 4? No, because it'd have to be even, right? Can't be divisible by any even numbers. How about 5? 5 times 15. Now we know that because the product is negative, one's positive and one's negative, because the middle number is positive, that means the bigger of these two numbers has to be the positive, the smaller one is the negative. Right? So that's x minus 5, x plus 15. Right? So we have standard form equals 0, convert from the standard form to the factored form. What do we do next? Set each factor equal to 0. X minus 5 equals 0. X plus 15 equals 0. So x equals positive 5. X equals negative 15. Normally, if you have like what's in parentheses is 1x, right? 1x minus 5, you probably just could say right away, oh, it's going to be 5. You know, what is the value of x that's going to make that factor equal 0? 5. 5 minus 5 is 0. Right? So most of the time when you get to this point, the answer is just like by inspection, it's 5. Like what number would I plug into x to make x plus 15 equal 0? Negative 15. You could probably see that just right away from there, and without having to set it up as a separate equation. That won't always be the case. Sometimes your factors are not 1 times the variable. Then you got to solve it. Okay. You know what you want to do, you're going to get questions on quizzes, on tests where it says solve by factoring, right? So you start out here, maybe you put it into the standard form equals 0 and you factor, and then you don't answer the question. Remember, the point is to answer the question, what are the values of x? Don't just stop when you've successfully factored the problem. Make sure that you've actually answered the question, what are the values of x? That's a common mistake, right? You see it as a factoring thing, so you just do the factoring and you walk away from it. Okay, try this one. You have to do pretty much just what we did on the last one. Did we get everything on one side, 0 on the other? Remember, if you have homework from a couple of days ago, you've got these already factored in your homework. Good job. Brandon, got it? Anybody else get it? Sophia, did you get it? Yes. Did you get it? Okay, remember, they're negative. Oh, hold it. Oh, you changed that. That was a plus 22. But other than that, you got it right. Good job. Right, so what did you have to think of? Two numbers whose product is 40 and is, yeah, and what did you come up with? 20 and 2, right? 20 and 2. Okay, so what are the values of x that make that true? Okay, okay, you could set it up, x plus 20 equals 0, so x equals negative 20. Or just say it, negative 2. Get it? Okay. So that was an example of solving it when the factoring to be done was the simple quadratic, right? They're not all the simple quadratic. If you remember that the thing we did after that was greatest common factor. And you should maybe remember we did this problem as a factoring problem. Now we set it up as an equation, right? What is the greatest common factor between 25b squared and 20b? Okay, in terms of the numbers, 5, right? But what else should be in the greatest common factor? Because this is like 2 factors of b here, right? b times b, and this is 1 times b. They both have at least 1. So you take out not just the 5, but 5b, right? And then what was left inside the parentheses, right? If you divide the 25 by the 5, you get 5. And b squared divided by b means you're taking away one of the b's. What's left is the other, right? And how about the last term? What is 20 divided by 5? It's going to give us 4. And b divided by b, b over b, anything over itself is 1. So that's it. All right, that was the factoring we already did of this problem when we did our homework a couple days ago, a couple lessons ago. Okay, now we're at that point. It's in factored form. What do I do with each factor? Set them equal to 0, right? 5b equals 0. That's this factor, right? And the other factor is 5b minus 4 equals 0. So that gives you 2 equations to solve. All right. If 5 times b equals 0, what does b equal? 0. I mean, you can divide both sides by 5, but what's 0 over anything? b equals 0. I mean, really, you can look at 5b equals 0. That's, again, zero product property. If you make 0 through multiplication, that means one of your factors equals 0. And it can't be the 5. 5 is not a variable. That's a constant, and it definitely does not equal 0. So what has to be 0? The b has to be 0. Right? So you could have just recognized that right there. B has to be 0 there. Or you can set it up and solve, as long as you don't get confused about what you're doing over here. How about this one? How would we solve? Add 4, divide by 5, right? Add 4. 5b equals 4. b equals 4 over 5. You know, one thing to keep in mind, because we always miss these kinds of factors as being a source of a solution. We don't recognize it for what it is. But remember, whenever you've got a variable and there's no plus or minus after it in that factor, then 0 is the solution. And 0 is the solution there. And here, some of you, will probably always have to set it up like that and solve. You can just try to figure out, let's see, I need to multiply by something that cancels this 5. That means it has to have 5 in the denominator. And that leaves a 4 behind, so I got 4 minus 4 is 0. So that would be 4 over 5. 5's cancel, 4 minus 4. I mean, a lot of times at this step, students will just say, okay, 4/5, I can see it. I see how the denominators cancel. I see why that does it. Right? I would say common mistakes are not seeing that as being a source of a solution, and then just thinking after we've gone through so many of these, like the previous couple, where you just say 5 and negative 15, or negative 20 and negative 2. You get used to just looking at the factors and saying, okay, well, that's got to be it. And then you just want to come here and say 4. The answer is 4, because you see the minus 4 there. But it's not the same, because it's not just 1 times the variable there. It's 5b. So it's going to be a little bit different. Okay, try that one. That was another homework problem we had for factoring. Now we made it into an equation. You've written minus 2x, okay. So when you divide 2x divided by x, there's 2, 2, minus 2, x minus 2, in parentheses, equals 0. Yeah. What was the greatest common factor? You doing it? What is the greatest common factor between those two? X. So factor out an x. Where do you get the minus 1 here? No, you can't. I mean, all you can do here is say there's a common factor of x, so that goes outside parentheses. I think you're looking at it like it might be like a 3-part inequality, but it's not. It's just 2 terms. So you're not going to have that. Anybody else get it over here? X equals 2 is 1, and x equals 0 is the other. Yep. Right, right. Right, right. Did you get 100? Let's see. When you factor an x from that first term, only an x is left, not a 2. Now you take away an x from that, that's the second term. Right? The first term, you're going to have an x. The second term, when you take away the x, you're going to have a minus 2. So that should be x times x minus 2. Okay. So greatest common factor was an x. Right? It should have factored like that. And then, again, a standalone x has no plus or minus afterwards. 0 is the solution, right? And then what number would you plug in for x here to make x minus 2 equal 0? 2, right? Okay, remember this kind of factoring was the not simple. So we're going to have to go through a few steps because this number is not 1. We go through some steps. We're going to go 2 times 15, 30. What are the factors of 30 that add up to negative 11? Are they positive or negative? They're going to both be negative. So just think, what factors of 30 will add up to negative 11? 6 and 5, right? So it'll be minus 6 minus 5. Okay, what did we do with those two numbers? Yeah, we split up the middle term. 2m squared minus 6m minus 5m plus 15 equals 0. We grouped. Right? We factored each set of parentheses. Ooh, what is that? And then if we got to the right spot, we had the same thing in parentheses in both terms, then we take that m minus 3 here, and what goes in the other set of parentheses is 2m minus 5. So it's a harder factoring problem, but we still got to the same place, right? We went from a standard form to a factored form. Now what do we do? Set each factor equal to 0, solve, right? And, you know, this m minus 3, can you tell me what the answer is going to come out of there? 3, right? We could tell that without setting it up as an equation, right? M equals 3. But this one right here, the 2m minus 5, not so easy, right? You can't just say 5. That wouldn't work. Because it's got something other than a 1 in front, you needed to say 2m minus 5 equals 0. Solve it. Add 5, divide by 2. which again, you might have recognized. Some do. And if you do, I don't begrudge you that at all. That if you could just see 5 over 2, the 2's would cancel. 5 minus 5 is 0. If you see it at that point, that's fine. Okay, that's good. I think I got it. Are you all right, Brandon? Okay. Try to do the same thing with that one. What do you have to do first? You got to get the 28 onto the other side, right? It's got to be standard form equals 0 before you start. And, I did make copies of this multiplication table thing if anybody wants one just to have. Not. Does anybody want on this side? If you want, you keep it. No? Okay. They're sitting here if somebody wants it. Because what number are you going to have to figure out the factors of? What you got, Jose? It's 2 times negative 28 is negative 56. That's what you're trying to find the factors of. What were the factors that worked? Anybody? All right, 2 times negative 28, you should have been trying to find factors of negative 56, which means one's positive and one's negative, right? So you got to think, what are the factors of 56? That's why if you need multiplication tables, don't be too proud, because that's a pretty basic multiplication table thing. What are the factors of 56? I mean, 1 times 56, 2 times 28, 4 times 14, 8 times 7, right? But which one is going to be the negative and which one is going to be the positive? The 7 is the negative because it adds up to a positive number, right? You got to know 7 times 8 is 56, right? All this stuff is going to be impossible if you can't figure that out like in about half a second, right? So what do we do with those numbers? 2z squared minus 7z plus 8z minus 28. Then group the first two, group the last two, right? And I did it on the same line because I have a plus in the middle and it doesn't change the value of anything when I put those parentheses. It's only when I got a minus there that I have to be a little more concerned about it, all right? What's the greatest common factor in the first one? Just the z, right? Not a 2. 7 is not divisible by 2. So you just take out the z. 2z minus 7. plus, what's the greatest common factor between 8 and negative 28? 4. 2z minus 7. So this factors as z plus 4 times 2z minus 7. Okay, so what solution is going to come from the z plus 4? Z plus 4 equals 0. Solve. Z equals negative 4. That's one answer. 2z minus 7 equals 0. 2z equals 7. Z equals 7 halves. Okay. Okay, this was an example of a different kind of factoring, perfect square trinomial, right? 4 is a perfect square, 5 is a perfect square, right? This is 2z squared, this is 5 squared. Is there any chance that this middle term is 2 times 2 times 5z? The answer is yes. Right? 2 times 2 times 5 is 20. So this thing will factor as 2z minus 5 squared. Why minus 5 and not plus 5? Because the middle term is negative. So it must be that both of those are negative. Okay. Now we've got to find the solutions, right? All we've done is factored so far. So we need to take this and say 2z minus 5 equals 0. So 2z equals 5. Z equals 5 halves. Okay, but what do we say about quadratics? When we solve them, how many answers do we expect? You expect 2 answers, right? But because it's a perfect square trinomial, I mean, really what you've got here is 2z minus 5 times 2z minus 5 equals 0. You do have 2 answers. It's the same answer twice. When we get onto quadratic formula, they'll use an example like this of being something where they say, how many and which kind of answers do you get? And this one will be an answer where they'll say you get one real solution. I mean, really, it's one answer twice, but that will be their answer to that question, which will make more sense after a couple lessons. Okay, how about a difference of squares? How does that factor? I think we just did this in the homework last night. How did that factor? Say again? Okay, well, tell me the factors. Okay. So what does that make the answers for this? 8 and negative 8. Right? If you have to, set it up as an equation. C minus 8 equals 0. C equals 8. C plus 8 equals 0. C equals negative 8. Good. Good. So you try that one. Again, another one we had in the homework last night. Okay, friend. Okay, you didn't solve it yet. What are the values of 2 that make that true? 2 and negative 2? 2 and negative 2? 2 and negative 2? Two and negative 2? Good job. You know, what's different about this one, when you do the difference of squares and you're solving an equation, the truth is that how many terms do you have here that have the variable in it? Just one, right here, right? I just have the x squared term. So I really can isolate the variable here, right? I could have isolated the x. I can't do that when there's 3 terms, but I can do it if it's just an x squared and a constant. I could have done it. I could have gone like this. X squared equals 4, right? I solve for the x squared, and then how could I turn that x squared into an x? Take the square root of both sides, right? And if you did that, the square root of a square is just the x. And the square root of 4 is, it's 2, but it's also negative 2, right? Because negative 2 times negative 2 is also 4. So you got, when you take the square root, you got to consider both. And you know that because here, when you solved, right, you got x plus 2, x minus 2. So x had to equal negative 2, that's from here, and 2. So it would be incomplete if you did it this way and just said 2. You would only have one of the answers. Right? Those are all the kinds of factoring that we did, set up as equations to solve. Right? So you make sure you got everything on one side, 0 on the other, convert to a factored form, use 0 product property, set each factor equal to 0. So this one was another one we looked at. Solved by factoring. Is this a difference of squares? Is 2 a perfect square? No. 18 is not a perfect square. What kind of factoring could we do first? Yeah, which is the greatest common factor? 2. So if you take the 2, factor a 2 out of both of these here, right? You're going to get 2 times x squared minus 9. And then what kind of factoring can you do inside the parentheses? It's a difference of squares. X squared minus 9, right? 2 times x plus 3 times x minus 3 equals 0. Right, so what would be the answers looking at that? Okay, negative 3, right? X equals negative 3. And x equals 3. Okay, well, what about that 2 there? Should we figure out an answer coming from that? No. Remember, the 0 product property says that when you multiply things together and you get a 0, it means one of the factors must be 0. 2 is a constant. It's not 0. It's never going to be the source of an answer. So never get confused with a constant that's outside. That's never going to be a source of the 0. Because I get that a lot. Students will say 2 is an answer because they see the constant there. So still, negative 3, 3. Finish. Okay. Which leads us to solving equations by graphing. Now remember, as I've gone over, several times I've shown the same slide that says, this is what we do with expressions, this is what we do with equations, this is what we do with functions, right? What do we do with functions? We graph them, right? We solve equations, we graph functions. So you can't graph an equation like that because it doesn't have a y in it, okay? What you do is, change that equation that's 0 equals a quadratic expression. Somebody got something going off here. Turn off these. Turn that equation into a function by replacing the 0 with a y. Does somebody have a phone to turn off there, Cody? Okay, this is something that you would graph, right? Because it's y and x in the same equation, right? You can't solve it, but what you can do is figure out all the points that satisfy that equation and graph them. But we would not be interested in the whole graph. We're only interested at the places where y equals 0, right? Because that's what we changed right there. We went from 0 to y. Now let's just look on the graph. Where does y equal 0 on a graph? Yeah, on the x-axis, right? Y equals 0 for every point along the x-axis. You're not above, you're not below, you're right in the middle. So when we graph, that'll be our strategy. We'll put it in the calculator, and we'll graph it, and we'll look to see where is it crossing the x-axis. And those will be the solutions to our problem. All right, we're looking for x-intercepts. But again, just like when we did the factoring and we had to have a standard form equals 0 to start, you've got to be at the same place here too. You have to start with something that is 0 on one side and everything else on the other, and then replace the 0 with a y. Okay. So here's that first problem that we did, right? X squared plus 3x plus 2 equals 0. So if you have your calculator, you could try this. You put it on the y equals, right, on that button right there. And on the first line, you put x squared plus 3x plus 2. And once that's in, you graph it. Now, if you do it, your calculator probably looks like, oh, it's not even on because I had to restart. It doesn't have the same window as the one that I'm showing you. Here, I zoomed in. So if you graph it and it doesn't look like this, do a zoom, which is this button right here, zoom to, enter, and you'll see that. Okay, so now we look for the x-intercepts, right? How many places do you see it crossing the x-axis? Here and here. So those are the answers to the equation, right? X equals, and that is -2, and that's -1. Again, if you have a hard time seeing it on yours because you're not zoomed in, then do a zoom to and see whether you can see it. Just like should have exactly that picture there. Yeah.
So that will be the final answers.
X equals -2, x equals -1. Is anybody trying it and not getting it? Need help with that? I mean, I could tell you that most are not even trying, so there's not much I can do for you if you're not going to try. But if you tried and you weren't getting it, glad to help you out. Okay, let's look at another one. Solve by graphing, right? So what do I have to do to this one first? Yeah, let's get everything on one side, 0 on the other. How am I going to do that? Add 24 to both sides. X squared minus 11x plus 24 equals 0. Replace the 0 with a y. Y equals x squared minus 11x plus, what did I do there? I said 48 and I meant to say 24. So we go to our calculator. Clear. X squared minus 11x plus 24. And if you just have a normal zoom on it, this should look like that. So what are you interested on that graph? Only those 2 points right there. And what does it look like their values are? 2 and 8. 1, 2, 3. Yeah, 3 and 8. So your solutions would be 3 and 8. I believe the next slide. Okay, let me do this one. Let's do this one. Try that one. Put it in the calculator. See if you can come up with the answers. Sure. Thank you. Yes. Let's see. Plus, minus 8. So it's what is going to be? Negative. What are the answers? Try to do a zoom 6 to get you back to normal. There you go. You were too zoomed in. You couldn't see it. So what does it look like the answers are? No, not down there. There and there. Remember, you're looking for x-intercepts, not y-intercepts. What do you think your answers are there? Negative 4 and 2. Yeah, don't use the trace. Let's see. You don't have that in there, right? There's no x there. You don't have 2x. You have, right? You put 2 squared, not 2x. He's got it. So it should have been x equals negative 4, x equals 2. Now, if you look, this is what you would have seen in your calculator. Right? It should have looked like this. Negative 4, positive 2 is the answers. Remember that you can also look in the table of values. Right? If you look above the graph button, it says table. So if you've got that already in there, you go second with the second button and then the graph button, and then this should come up. And you're looking for where is it that the y values are 0. And wherever the y values are 0, the x values are the answers. Negative 4, positive 2. Now, we'll probably get into this more in the next chapter. Tonight's homework will not be any of this because you can't take the calculator home. It's just be solved by factoring. But imagine this picture right here, right? This is the normal shape of a quadratic function, and it's crossing in 2 places, and we know we're supposed to get 2 answers. But what would happen if their graph was up here and it never crossed the x-axis? That's going to be something that we're going to have to deal with because that happens. Sometimes your parabola does not cross the x-axis. Then how do you know the solution? Okay, solve by graphing, confirm in the table of values. So again, try this one just as a means of practice. That was the one we already did. What did we say the answers were? Remember when we solved by factoring, we took out a 2, that left x squared minus 9. We factored.
Oh, x equals -3.
Yeah, x equals 3 and -3. So you definitely want to come up and clear. 2x squared minus 18. You know, if ever you like hit your graph button and you're not like getting the window that you want, then you hit zoom, and the normal zoom is 6, zoom 6. That'll always get you right back to the middle, exactly what you're looking at. Not zoomed in, not zoomed out, zoom 6. And what is we can see our answers that we expected, -3 and 3. And then again, go to the table of values and look at that. Second graph, I definitely see at x equals 3, y equals 0, and then I scroll up a little bit, and I can see at -3, y equals 0. There's my 2 answers. So you confirm there. There will be times that you look at the graph and it's like really close, but it's not exactly in the table of values, right? But if it is, that's good. And most of the time, what we're doing, it is most of the time, not all the time. So again, we just did 2 strategies today, right? We did solve by factoring, solve by graphing. And I believe the next one we're going to do is going to be solve by quadratic formula. So like I said, all of these problems here are solved by factoring because you don't have a calculator to take home and do what we learned to do about that. And it's not just the odds. Just do them all. They're all different kinds of factoring.